So yes, at the end of today, we've just got talks from two of the section directors. So myself and Mike Frost. Oh, there we go. I thought you'd scalp it. So the core of what the BAA does is down to its sections. So we have sections for all sorts of different objects. Because of history, oh dear, sorry if you couldn't hear me. Because of history, most of those sections relate to solar system objects. But does this clip on somehow?
Yes, it's very tiny. You have to have good vision to see it.
Okay, got it. Woohoo! But one of the sections covers comets, and that's the section that I lead. And I'm not biased, but I think comets are about the most interesting thing that there is in the sky. Basically because whenever you go out to observe a comet, you never quite know what the comet's going to be doing. Comets are, David Levy once said, comets are like cats. They have tails and they do what they want. And that is indeed what comets do. So just quickly, I'll just run through a bit about comets and then a bit about what the section does. So I think everybody knows that the comets that we see in the sky, if we get a bright comet that shows up as this really spectacular thing in the sky, it all comes from a very, very small nucleus. So we had the discussion this morning about all these icy things that were made and then thrown out far into the solar system. So most of the cometary material are icy objects that were thrown a long way out in the solar system, and they stay in deep freeze for pretty much all of their lives. And then something causes them to fall into the inner solar system, and they come in on a big long looping orbit. They get warmed by the sun, and the volatiles in that nucleus sublimate, turn into gas, comes off the nucleus, takes dust with it, and that forms what we call the coma, which is the kind of atmosphere of the comet, the fuzzy bit at the front. And then the gas and the dust in the coma gets pushed away from the coma to form the tail. So the nucleus is so small, we can't actually see it with any telescopes from Earth. We can never see the nucleus of a comet with telescopes from Earth, but we can actually see it from spacecraft. And here are just a few examples from spacecraft that have flown by cometary nuclei. Comet Wild, Comet Borrelly, and this most famous one, Comet Halley. So Comet Halley is the comet that goes around the solar system once every 76 years. It was last back in 1986, if any of you can remember that, and was a huge disappointment because it was a really bad pass in 86. And if you wait till the next one, which is 76 years after 1986, and I can't actually do the arithmetic standing up now, it's even worse, so it's not really much point waiting around for that one. But Comet Halley, you can see all these nuclei, they're not round. These nuclei are far too small to pull themselves into a round shape. They're kind of peanut shape and various other bowling pin shape. But you can see here with Halley quite clearly you've got dark side, the sun's over here, so on the night side not a lot's happening. On the day side the sun is heating up that nucleus and you're getting jets of material from it. The comet that we know better than any other comet is of course this one, Comet Churyumov-Gerasimenko. Discovered by those two people, 67P if you don't want to do the tongue twister. This is the comet that the Rosetta spacecraft went to. To give you an idea of scale, I think it's about 5 kilometers long. When it was first seen, it looked a bit like a rubber duck, so it's got a head and a body here. And certainly when I do STEM stuff in schools with younger kids, taking rubber ducks in and saying this is what a comet is and having it rotating and getting the kids to see how the brightness of that rubber duck changes as you turn it around is quite a good way of introducing people to rotational deconvolution modelling and all that kind of stuff at 5 or 6. Anyway, this is the best nucleus that we know. In terms of what we see in the sky, of course, we don't see the nucleus, we see the result of the nucleus. And I wouldn't want to oversell or missell comets. So sometimes comets come along that are really, really bright, and you can see them clearly in the sky, and even people who are not really comet observers can see them. Most of the comets, though, that we observe day to day are really faint, fuzzy things, which you've got to be a real comet nut to really find interesting. But this is some examples of some of the brighter comets. So those of you who are old enough may remember this one. This was 1996. This is a comet called 1996 B2, Hyakutake. It was a really small comet, but it came really close to the Earth. This comet was mainly a gassy comet, so it's got a gas tail here, but not much of a dust tail. But it was a really nice comet. It's the best comet I've ever seen, actually. Comets are a bit like buses, though, and so you go for ages without having good comets, and then two come along at once. And in 1996 and 97, we were very lucky, because in 97 we had this one. This is the big daddy of all comets. This is Comet Halley, 1995-01. It was a massive comet. It's one of the largest cometary nuclei that we know that's come into the inner solar system. It was possibly 50, 60 kilometers across, really huge for a cometary nucleus. And it was a really spectacular comet. Those of you who remember this will remember that it hung in the sky for months and months in the first part of 1997, and everyone saw it. You didn't need to be an astronomer to see this. It was just, it stood out. We don't get comets like this very often. In fact, hardly ever. So this was 1997, and we're now in 2022, and we've had nothing like this since then. But anyway, this shows quite nicely a comet with two tails. You've got a gas tail and a dust tail here. And what the comet section does is observe those comets. It measures them, we measure them, our observers photograph and image them. And we were really lucky 2 years ago, during the height of lockdown in the summer of 2020, to have a really lovely comet. This comet was discovered by a spacecraft called Neowise, so it's called Comet Neowise, but in fact there are loads of Comet Neowises, so you have to use the actual real designation for it. So if you're a real comet nut, you would call this 2020 F3 Neowise. It was a lovely comet. It coincided with some really nice weather for the southern part of the UK, but it was right in the middle of summer. So this is the comet rising above my local football field in Chelmsford in Essex, which is where I live, basically in the summer twilight. It was a lovely, really nice comet, nothing like Hale-Bopp, but a really bright comet. But what surprised me was that, to me, it was a really bright comet. It was something that I could see easily, naked eye, very easily in binoculars. But friends and colleagues at work who weren't really astronomers, I said, there's this comet, go out at night and just look to the north, northeast, northwest, depending on what time of the day it was, and you'll see this wonderful comet. Well, lots of them couldn't. And the reason for that is the reason I think that a lot of people get confused in astronomy is you see images of comets, a bit like this picture here, and the comet really stands out. You've got the dust tail, you've got the blue gas tail. I mean, that really stands out. When you actually look at this thing on the sky, and this was quite a bright comet, it got to about second magnitude or so. When you look at it on the sky, it's actually quite difficult to see, and unless you know what you're looking for, it's, not obvious. And so people would go out, they'd look in the direction I said, and they wouldn't see anything. And then I would see them a few days later, and I'd say, did you see the comet? Did you see the comet? No, didn't see the comet. But if you're actually with people, and this is one of the things that local societies can do really well, if you're with people and you point out the comet to them, and you say, yes, that's the comet, that's what you're seeing there is the comet, they'll get really excited because they can then see it. So one of the big problems is people, I think that photos are what they will see on the sky, and we all know that that's not the case. Things are much more difficult to see than you'll see in a photo. Comets are very dynamic objects, and one of the things that we can do now with the cameras that we have on normal amateur telescopes is to actually take images and then image process them to show motion in the comet. So this is that comet. This is 2020 F3 Neowise. This is showing the inner part of its coma. So right in the middle there is the nucleus that you can't actually see. But I don't know whether you can see it on the video. There is a spiral structure here that's actually rotating around. And that's, if you think of the comet nucleus as having a bit like a water sprinkler rotating. That then rotates out into the coma. And then behind it you've got this tail, which is being affected by the solar wind. So this is a gas tail, it's charged ions. The solar wind is running into that and pushing the tail back and compressing it. So what you're seeing here is features in that tail as the solar wind goes past. So well-equipped amateurs can do amazing things now with bright comets. The trouble is bright comets don't come along very often. So we have to satisfy ourselves often with much fainter objects. But much fainter objects can turn into bright comets. So this is an example of one that was discovered last year. This is 2021 A1, Comet Leonard. You may have heard about that in the news. So most comets now are discovered by professional survey telescopes when they're a long way out from the sun. So they're really faint. And what amateur observers can do is, if they've got the appropriate equipment, they can get their telescopes on these comets and they can image them early on, and they can measure very precisely the position of the comet relative to the stars. That's called astrometry. That astrometry can then help professionals to calculate the precise orbit of the comet. So the one thing that we do know about most comets, fairly shortly after they're discovered, is where they're going to go. We know what the orbital path is that they're going to follow. The thing we don't know, really, is how they're going to perform, because the media, and in fact some astronomers who are not very good at handling this kind of thing, will try and predict how bright a comet will be from observations made when it's really faint in the outer solar system like this. So once you know what the orbit is, and with this comet it had an interesting orbit that was going to take it close to the sun, so potentially make it quite a bright object, people will extrapolate from this faint magnitude and say, oh, you know, this is going to be a really spectacular comet. And quite often people will do that, and the general public gets very disappointed because they read in the paper or on the media that this bright comet's coming along, and then they don't see anything. So one of the things we try and do in the BAA Comet section, if you look at our Comet section web pages, is include information about the likelihood that certain comets will be visible, observable, by people who really know what they're talking about. So we have analysts who really understand how comets behave. So if ever you read anything in the media about a comet coming along that's going to be bright, go and have a look at the BAA Comet section web page first. Hopefully we'll have some information there about what the comet will really be doing. This comet, though, did really blossom. This is what it looked like as it approached the sun. Lovely comet, Comet Leonard. Unfortunately, not visible from here. This was a southern hemisphere object. But this was an image taken from a remote telescope in Namibia. So even if you're in the UK, you can join up with these robotic remote telescope systems and take images of objects when they're actually not visible from here. So either because of the weather or because of where they are in the sky. Just a quick thing about our archive. The Comet section's been around for a long time. It's been around since shortly after the BAA started, which was at the end of the 19th century. It has huge archives. It's got lots of really interesting stuff in its archives. These are some of the cardboard boxes that those archives are in. Those archives are stored in various different places. But we started scanning them, and we've got a whole host of different observations. This one I really like, though. This is a letter from a person called Bernard Lovell at Jodrell Bank, written on the 3rd of May 1957. So that's before Sputnik 1 went up. Talking about some imaging of Comet Aaron Rowland that he'd done. This is in our archive. It's a really lovely letter. What's amazing to think is that when he wrote this letter to Gerald Merton, who was my predecessor, director of the Comet section at the time, he was almost bankrupt. This was the point where his Jodrell Bank project had massively overrun. He was personally responsible for a huge amount of money. It was only when Sputnik went up and he managed to track it that Lord Nuffield rang him up and wrote the cheque to clear the debts. So this is a really nice letter from Bernard Lovell at a time which would have been really stressful for him, talking about the comet imaging that they were doing at Manchester at the time. We have some really nice stuff from amateurs who are the real leaders of their time. And this is Brian Manning. This was in the days when comet photography was on film, really difficult. You actually had to go and guide the telescope, develop all the film and whatever. Brian was an amazing character, developed a lot of his own equipment, and he built lots of equipment to do astrometry himself in those days, when it was really difficult to do. In our archive as well, we've got newsletters from the early days of the Comet section. So this is from 1973. They're all available on our website. You can download them and read them, and they are really fascinating to read. The world was so different then. It was so different in terms of the technology that we had, but it was so different in the way that people interacted with each other as well. You know, you've got a printed thing here that came out every month. So I really, if you're interested in the history of observing as well, just go and have a look on the BAA Comet section website, have a look around. We've got all our archive there for you to have a look at. So just a quick thing about observing now, because I know I've only got a couple of minutes left. Astrometry, which is that thing about measuring positions of comets, used to be really hard. You had a picture on film. You had to have a microscope that could actually measure the XY coordinates of the comet. You then had to calculate the comet's position and send the result off. And I've done this once many, many years ago, and it took me a whole afternoon to get one comet position measurement using a technique like this. We now have software and digital cameras. This is a piece of software called Astrometrica. I can do astrometry on a comet image now in about 20 seconds. Hugely easier than it used to be. The other thing we do is we look at the brightness of comets. We have techniques for measuring the brightness of comets so that we can calculate their light curves and predict what they're going to look like. That's quite difficult sometimes because comets are fuzzy objects, quite difficult to measure their brightness, but we have techniques which try and standardize the way that people will do that. We've got a website, that's me in disguise, which has got all this stuff on. So if you go to our website, you'll find stuff on various comets that are around at the moment, and freely downloadable are Comet Section Observing Guide. So this is a PDF guide that goes into all the details about doing comet observing. So if you're interested in doing comet observing, even if it's just observing a comet with pair of binoculars, trying to make estimates, right through to using your telescope and your new observatory with digital cameras and taking some images and measuring it, it's all in here, and it's all free for you to use. So it's free for everyone. We obviously would like people to join the BAA, become a member of the BAA and support the work we're doing. But all of this is free to download, so even if you're not a member, you can download it from our website. We organise things. I've just organised a conference. It was terrible. I had to go to Prague and stay in a hotel that had a brewery attached. But we organised a comet conference at the Stefanik Observatory in Prague, which was a pro-am conference, so looking for how amateur and professional comet observers could work together. And lots of really interesting ideas has come out of that, and this is from all over Europe and all over the world. So it's a really big cooperation between professionals and amateurs all over the world. It was a really good workshop, lots of good stuff. There'll be a write-up probably in the next BAA journal on this, and quite a lot of interesting stuff's come out of it about how we manage comet observing through Europe and around the world. And just finally, there is a comet that you can try and observe at the moment. It's not very bright. It's not anywhere near kind of Neowise bright or Leonard bright, but it's bright enough that you should be able to see it in a relatively small telescope. It's a comet called 2017 K2. It was discovered in 2017, a long, long way out. And it's finally coming into the inner solar system. And as it comes into the inner solar system, it's been brightening. It's currently in a fucus. It's just about here, actually. It's just past that bright star. But it's moving very rapidly south. So you've got a few months now to have a go at observing this comet. It's about 9th magnitude. I've had reports, visual reports, from people observing it with telescopes as small as 6-inch aperture, so you certainly should be able to see it in your C14. It's a good comet to have a go for. Put a DSLR on the back of that telescope and have a go at taking an image of it. Here's a picture of it I took myself the other night. This is about half a degree here, so it's got a tail stretching up to the north. It's a comet worth observing. It's a typical example of the kind of medium-level comet which you ought to be able to find, visually, but which is actually relatively easy to find if you image it. So probably you would be able to image this now with a fairly small telescope and a DSLR camera, for instance, and you get the characteristic green colour of the coma coming from the carbon emissions, and then this more neutral colour, which is the tail of the comet behind. So I hope in that very brief talk I've kind of infused you with comets. Comets are just fascinating things. You never know what they're going to do. Never believe people who tell you that they can predict how a comet will appear or what they will do. Just go out and observe it. Every time you observe a comet, you're adding to our knowledge of comets in general, because they are always different, they are always changing. And they're really fascinating things to look at, fascinating things to find in the sky, and just amazing to think that all of this stuff in the comet, and even the really bright comets we see with big tails, all of it's coming from a really, really small nucleus, only a few kilometres across, that has been basically in deep freeze since the solar system was formed 14 billion years or so ago, whenever it was. So anyway, that's comets. I'm going to hand over now to Mike, who's going to do the same thing for the historical section.